Today we will discuss about the case. This is the speedometer part and the material for case is 40% torque filled. TFPP means torque filled. What is 40% torque filled? 40% torque filled means if suppose this percentage will be higher then this part will be more stronger, or we can say it will have more strength. So in this session I will explain you what type of tooling feasibility points we get from tool room. So here you can see tool room person showing the core cavity for this part. So this outside portion will be made in cavity side and this bottom side portion will be made by core side. So this red color line showing the parting line for this part. So what is parting line? Parting line is a surface where both core and cavity surface matched. So here he is suggesting that there is 3-degree draft should be in cavity side and this is the core side. Here you can see this is the parting line. This red color is in showing a parting line. Why we have made this type of parting line for this hole? Because this hole having a undercut, so half of portion of this hole will be made in cavity and second half portion of this hole will be made in core side. So this is the parting line showing. He is suggesting that undercut found in this area need to correct it. Okay, so here you are able to see this one. This is the undercut. So we need to match this ID of hole with this surface so that this undercut will be removed. Here also these two red color lines showing this is the undercut. So there will be problem in ejection. We need to correct. Here you are able to see the gap between this area is 0.5 mm. There is a problem in tool manufacturing. So he is suggesting to increase the gap minimum 1 mm. So this gap should be greater than 1 mm. This gap is showing 0.5 mm. So we need to maintain here minimum 1 millimeter gap so that the tool will be manufactured easily. There will be no chance of breakage of the tools during the manufacturing. So ensure that always gap should be minimum 1 mm between two walls. Sharp corners should be removed in this zone. So we need to provide minimum radius for the sharp edges. Here also he is saying that need to provide hole here for maintaining bolt case height. This is the design requirement. We need to provide a hole here. Here he is saying need to reduce the rib height 1 mm here. The height seems more in this zone, so as per tooling point of view we need to reduce the height by 1 mm downside. Here also he is suggesting that solid material found in these boss areas. This is the boss. I will show you in 3D model. This is the boss area. This is the solid portion. So to avoid the sink mark issue, we need to provide the hole in back side of this mounting boss feature. So need to provide core out for these three features. Here he is suggesting that need to provide connecting rib here. For this feature we found that the hole depth is 27.4 millimeters. This depth is much more. So when we will go for tool manufacturing for this hole, there will be a pin height 27.4. So we will face an issue in manufacturing, or there will be chances of bending of the pin. So to overcome this issue, what we will do, we will reduce the hole depth from 27 to 10 mm. Here also you are able to see this wall thickness we found 0.9 millimeter. So we may face the issue of short filling. So for that wall thickness should be between 0.9 to 1.2 millimeter. So we need to increase the wall thickness for this zone. Here also we have done the draft analysis in Creo software. So we found that there is a negative draft in outside area. This is red one. This is the negative draft. So we need to correct this by providing the draft for this zone. I will show you in model what type of draft we need to provide here. This is the case model. Suppose if I take the top view, or we can say this is the tooling direction. So for that you are able to see there is a uniform draft provided outside of the wall. So this is the corrected way for providing draft. So product designer ensure that draft should be provided in such a way that part will not get stuck in the mold during ejection. Now come next. Here you are able to see the wall thickness is very less here. So we may face the short filling issue So to avoid this issue, what we will do, we will increase the wall thickness from 0.26 to 1.2. So here wall thickness should be near about 1.2 millimeter. This is the 0.26. Here we are found that there is a sharp edge. This is the sharp edges. So to avoid sharp edges in all core and cavity areas, suggest to provide radius minimum 0.5 or 1 mm. Here also it was earlier sharp edges. Now engineers suggest to provide full round radius here. To avoid sharp edges in all core and cavity areas, suggest to provide radius. So here we are able to see all are the sharp edges. So this is the 3D model of case. These are the mounting features. This is also mounting feature, and these are the locators. This is the mounting features. So different type of features we have provided in the case as per the design requirement. Now I will show you how to perform draft analysis for the plastic case part. So let's go to analysis. This one is the draft. So it is asking for the surfaces. So click on this model. Now it is asking for the direction. So give any vertical direction. So here all edges are the vertical. So I am picking this one. So here you are able to see this blue color showing is 3-degree draft, and red color showing is minus 3-degree draft, and this color is showing there is no draft. So here we are able to see outside area there is no undercut, and here also draft are provided. If I set the view of this one, you are able to see there is no undercut for this feature. So this is the way we can check where draft as given or where draft as not given. Suppose we can see in some features draft is not given. So by using this tool we can check the draft is provided or not. Suppose not provided, then we can provide the draft by using this tool. So here also the draft as provided.